Portable generators often feature a 240/120-volt 4-wire outlet with two separate breakers. This design offers several advantages. Firstly, versatility is key. The generator can simultaneously power both 240-volt single-phase and 120-volt single-phase loads, accommodating a wide range of appliances and equipment. Secondly, load management is enhanced. Separate breakers allow for independent control of each leg, enabling selective shutdown in the event of an overload or fault. This can prevent damage to the generator and connected devices. Now let's address a common scenario: trip breaker. If one breaker trips, a 240-volt pump should not continue to run off the other leg at 120 volts. This is because the pump is designed for 240-volt operation, and operating it at a low voltage can damage the motor or significantly reduce its performance. A handle tie is typically used when a 240/120-volt source is fed from a single pole breaker. With separate breakers for each leg, a handle tie is generally not necessary, as each leg is independently protected. Feeding the generator through a stand-alone breaker is generally not recommended. The characteristics of the generator's breakers and the stand-alone breaker may not match, potentially leading to safety hazards or equipment damage. Now let's cover some recommendations for ensuring proper operation and safety. Firstly, use a load management panel. Connecting the generator to a load management panel with an automatic transfer switch and interlocks helps prevent hazardous conditions and ensures a smooth transition between utility power and generator power. Secondly, ensure proper breaker sizing. Select breakers that are appropriately sized for the generator's output and the load it will be powering. Using breakers that are too small can cause nuisance tripping, while breakers that are too large can allow the generator to be overloaded. Thirdly, maintain proper wire size. Use wiring that is rated for the voltage and current requirements of the generator. Undersized wiring can overheat and potentially cause a fire. Finally, carefully read and follow the manufacturer's instructions for connecting and operating the generator. The manufacturer's instructions will provide specific guidance on the generator's capabilities, limitations, and safety precautions. In summary, a 240/120-volt generator with separate breakers offers versatility and load management capabilities. However, it is essential to understand the potential hazards and follow safety recommendations to ensure proper operation and prevent equipment damage. Always consult with a qualified electrician if you have any questions or concerns about connecting and operating a generator. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations, including generators. Refer to relevant articles in the NEC for specific requirements and best practices. For example, NEC Article 445 covers generators, and NEC Article 702 addresses optional standby systems. Understanding the NEC requirements can help ensure that your generator installation is safe and compliant. Breakers play a vital role in protecting electrical circuits from overcurrents. They are designed to trip or open the circuit when the current exceeds a predetermined level. This prevents overheating and potential fires. There are different types of breakers, each with its own characteristics and applications. Common types include thermal magnetic breakers, which use a combination of thermal and magnetic mechanisms to trip, and electronic breakers, which use electronic circuitry to detect overcurrents and trip the breaker. When selecting breakers for a generator, it's important to consider the generator's output capacity, the load it will be powering, and the type of loads being served. For example, inductive loads, such as motors, can draw large inrush current when they start, so it's important to select breakers that can handle these inrush currents without tripping unnecessarily. In addition to breakers, other safety devices, such as ground fault circuit interrupters, or GFCIs, can help protect against electrical shock. GFCIs are designed to detect small imbalances in current between the hot and neutral conductors and trip the circuit quickly, preventing a potentially fatal shock. GFCIs are often required in areas where there is a risk of water exposure, such as bathrooms and kitchens. When working with electricity, it's always important to take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses, and never work on live circuits unless you are qualified and authorized to do so. Always turn off the power at the breaker before working on any electrical equipment. Wiring is another critical aspect of generator installations. The wiring must be sized appropriately for the voltage and current requirements of the generator and the loads it will be powering. Undersized wiring can overheat and potentially cause a fire, while oversized wiring can be more expensive and difficult to install. The NEC provides tables and guidelines for determining the appropriate wire size with different applications. These tables take into account factors such as the conductor material, the insulation type, the ambient temperature, and the number of conductors in a raceway or cable. It's important to follow these guidelines to ensure that the wiring is safe and compliant. In addition to wire size, the type of wiring is also important. Different types of wiring are designed for different applications. For example, THHN wire is commonly used for general-purpose wiring in dry locations, while UF wire is designed for direct burial in wet locations. It's important to select the appropriate type of wiring for the environment in which it will be installed. When connecting the generator to the load, it's important to use a proper transfer switch. A transfer switch allows you to safely switch between utility power and generator power without creating a backfeed, which can be dangerous. A backfeed occurs when power from the generator flows back into the utility grid, potentially energizing power lines that are thought to be energized. This can be a serious hazard for utility workers and the public. There are two main types of transfer switches: manual transfer switches and automatic transfer switches. A manual transfer switch requires you to manually switch between utility power and generator power, while an automatic transfer switch automatically switches to generator power when the utility power fails. Automatic transfer switches are more convenient, but they are also more expensive. When selecting a transfer switch, it's important to consider the size of the load you will be powering, the type of loads being served, and the level of automation you desire. It's also important to ensure that the transfer switch is compatible with the generator. Generators are a valuable source of backup power, but they must be installed and operated safely. By following the recommendations outlined above and consulting with a qualified electrician, you can ensure that your generator installation is safe and reliable. Remember, electricity can be dangerous, so it's always important to take precautions and follow safety guidelines. Here are some additional points to consider. Always keep the generator well maintained. Regular maintenance can help prevent problems and extend the life of the generator. Follow the manufacturer's recommendations for maintenance, such as changing the oil, cleaning the air filter, and checking the spark plugs. Store the generator in a safe and dry location. The generator should be stored in a location that is protected from the elements and is well ventilated. Never operate the generator indoors or in an enclosed space, as this can lead to a buildup of carbon monoxide, which is a deadly gas. Be aware of the noise level of the generator. Generators can be noisy, so it's important to be considerate of your neighbors. If possible, place the generator in a location where the noise will be minimized. When refueling the generator, always turn it off and let it cool down before adding fuel. Gasoline is flammable, so it's important to take precautions to prevent spills and fires. Use a funnel to avoid spilling fuel and wipe up any spills immediately. Never smoke or use open flames near the generator when refueling it. If you are not comfortable working with electricity, hire a qualified electrician to install and maintain your generator. Electricity can be dangerous, so it's important to leave the work to a professional if you are not qualified to do it yourself. In summary, portable generators with a 240/120 volt 4-wire outlet and separate breakers offer versatility and load management capabilities. However, it's essential to understand the potential hazards and follow safety recommendations to ensure proper operation and prevent equipment damage. Always consult with a qualified electrician if you have any questions or concerns about connecting and operating a generator. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional advice. Electrical codes and regulations vary by location, So it's important to consult with a qualified electrician to ensure that your generator installation complies with all applicable requirements. Always prioritize safety when working with electricity. Remember to always turn off the power before working on any electrical equipment. Wear appropriate personal protective equipment, and never work on live circuits unless you are qualified and authorized to do so. By following these safety precautions, you can help prevent electrical shock and other hazards. Generators can be a valuable asset during power outages, but they must be installed and operated safely. By following the recommendations outlined above and consulting with a qualified electrician, you can ensure that your generator installation is safe, reliable, and compliant with all applicable codes and regulations. Remember, safety is always the top priority when working with electricity. And finally, always consult with a qualified electrician for generator installations to ensure compliance with local regulations, safety, and proper setup for all your equipment.